Welcome back to the Art of Math. Sorry guys for a lack of videos in the past few days. I've been sick, but we're back in action. All right, today's video will be about solving inequalities, and in addition, 4 ways to express the answer. Okay, so there's pretty much 2 things you need to remember when trying to solve inequalities. The first one is it's just like solving equalities with one exception. So when I say it's just like solving equalities, I literally mean for almost anything you can think of. There'll be like tiny exceptions, and I'll try to point those out. Number 2. Okay, so here's the one exception. You have to flip the inequalities when multiplying or dividing by negative numbers. So let's run through one example. Let's say you have 4 minus 2x is less than or equal to negative 10. Now, we're gonna think of this as almost being like 4 minus 2x equals negative 10. Whatever you would do to solve this is the same thing you're going to do to solve that, with the exception of one step. So at first, let's subtract the 4 from both sides, or rather move the 4, same thing. Negative 2x is less than or equal to negative 14. Now, at this point, we're going to divide both sides by negative 2, which was that key point about flipping inequalities. So rather than saying that x is less than or equal to 7, we have to remember to flip this less than or equal to into a greater than or equal to. That's the only catch in solving inequalities. So if you guys remember this step, you will be fine. Now, one other thing I'd like to point out, instead of dividing by negative 2, you could also think of it as, maybe you're like, I don't want to divide by negative 2. Let's try differently. So we're going to move this negative 2x over, so we're going to add it to both sides, and we're going to move this negative 14 to the left. So that way we avoid multiplying or dividing by a negative number. So that's going to give us positive 14 is less than or equal to 2x, and x is greater than or equal to 7 rather. And if you notice, these are the same things, just written in reverse. Now, one other point I'd like to make other than flipping inequalities is if you have something like x squared is greater than 9, and you try to take the square root of both sides, you might get that x is greater than 3, but that's not necessarily true, because what if x were like negative 4 here? So when I said it's almost like solving equalities, keep in mind it's not the same thing, but for addition, subtraction, multiplication, division, other than negative numbers, multiplying and dividing, it pretty much is. But this is like one other little exception. All right, so that's our main example. At this point, you might be asking, well, why do we have to flip the inequalities? So let's look over here. I'm not going to give you guys a great answer, but hopefully I'll give you guys the beginnings of an answer. So if you consider negative x is less than 5, and just think about, when is this equal? Well, when x is negative 5, negative 5 is equal to 5. Now, if you want to make this true, would you go from negative 5 to, let's say, negative 4, or to negative 6? You would go to negative 4, because in negative land, things work in reverse. So think about this example, and it might convince you why, if you want to solve this directly, you would have to reverse this inequality to say x is greater than negative 5. Or if that doesn't do it for you, you could think about this example. 3 is less than 4, but if you tack on a minus sign, negative 3 is not less than negative 4. So that's why when we're dealing with negative numbers and you're multiplying or dividing, you have to flip inequality. So again, this is not a full explanation. In fact, I think you'd be better served if you try to figure out yourself why you have to flip the inequality. But these are 2 simple examples you may want to think about. All right, finally, how do we express the answer? You may see all these. This is not really the core of how you solve inequalities, but you may come across these, and so I want you guys to be familiar with all of these. So you may see the answer expressed as an inequality itself, just like we started with. You might see it in set notation. You might see it in a number line, and you may see a plot. All right, so that's what the ABCD is. So A, this is just an example. Let's say x is between 2 and 5. X is greater than or equal to 2, but less than 5. So that's one notation. Now we're going to see this expressed in set notation. So the way we're going to denote less than or equal to is this bracket. Now on the right side we have a parenthesis. So parentheses means it does not include the 5. The bracket means it does include the 2. So if you just have a strict less than or a strict greater than, you would use a parentheses, and a bracket would mean including the equal sign. And the comma just means from 2 to 5, inclusive of the 2, not inclusive of the 5. Now, if you wanted this on a number line, you would simply shade the circle for 2. You shade the whole number line from 2 to 5, and you leave this as an open bubble for the 5 because we're not including the 5. So the way I remember it is shaded, just like on a multiple choice exam, means you're selecting it. An open bubble means you're not selecting it, so 5 is not included in this interval. Also, you may see it as a plot. So let's say we have x's between 2 and 5. This solid boundary on the left means it includes the 2. So this is 1, 2. And the one on the right, which so this would be 1, 2, 3, 4, 5, the 5th tick mark. The reason this is dotted means it does not include this border. So the way you represent greater than or equals to is a shaded line on the border, and just strict less than or greater with no equal sign would be a dotted line. And you just shade the region to show it's anything in this region. So that's just common ways you might see it represented. And again, remember, this is the x-axis, so x can be, let's say, 3, and y can be whatever, so we're in this region. Now, second example, let's say you have 2 different intervals, so x is less than or negative 4, or x is greater than or equal to 2. That's one way of representing it, using our standard inequalities. Or we're going to write this way in set notation. So this letter U looking thing means union, which means we include both this range and that range. So that union is the equivalent of this or. That parentheses next to the negative 4 means we're not including the negative 4. So it could be negative 4 or lower, all the way up to negative infinity. Now, technically, you can never reach negative infinity, which is why we put a parentheses and not a bracket. But you can go all the way to negative infinity. So the parentheses versus bracket with the infinities is just a technical issue. You always put the parentheses. Same thing here. The 2 is inclusive, so that's why that's a bracket. And on the right is a parentheses, because technically you can never reach infinity. You can just go towards infinity. So that's what's going to indicate any one of these 2 intervals here. So it's from 2 to infinity, inclusive of the 2. From negative infinity to negative 4, not inclusive of the negative 4. Same thing here. We've left the negative 4 unshaded, and the 2 we've shaded because it includes the 2. And again, you highlight the number line portion. Same thing here. We have this region on the left, negative 4 leftwards, that we've shaded. This is dotted because we're not including the negative 4. This is not dotted. This is a solid line to indicate that it is inclusive of this 2 region, x equals 2. So these 2 regions combined would be the answer. All right. This is not really to illustrate all 4 notations, but just to show you, if you, let's say you have y is greater than x, for the plot, you could have a slanted inequality. So when you're shading inequalities here on a plot, it could be all sorts of interesting regions, and this is just to show you the beginnings of something that's more interesting than a vertical line. So y equals x would be this diagonal line, and since we want y greater than x, that means for any x, let's say x is 5, y would have to be above it. For x is negative 4, y would be above it. So that's why everything is above this line. All right, I'll leave you guys with that. Again, the main thing is to solve inequalities, treat them just like equalities, but don't forget to flip the inequalities when multiplying or dividing by negative numbers. I'll see you guys in the next video.